a cubic function has rule fx equals to ax cubed plus bx squared plus cx plus d. Okay, 4 variables. And then it's not given a graph. What has been given is some random point, like x equals to 0, y equals to 1. Okay, you have 0, 1. You have 1, 4. You have 2, 17, and negative 1, comma 2. There are not some, like, except the first one is y-intercept. All of these are not some, like, x-intercept or point of inflection. So you can't use what we have done before to write the equations directly. So for this one, I just can set up simultaneous equations and solve for it. Like 4 variables, 4 conditions, we can write 4 simultaneous equations. But for the first condition, when x equals to 0, y equals to 1, that will give you d equals to 1. Okay, that can give you d equals to 1. So it can reduce it to 3 simultaneous equations. So when x equals to 1, you have a plus b plus c plus 1. Okay, don't write d plus 1 equals to 4. That's right here. D gives you 1. And this can be reduced to a plus b plus c equals to 3. And 2, 17. Okay. 2 gives you 8a plus 4b plus 2c plus 1 equals to 17. Okay, substitute 2, 8a plus 4b plus 2c plus 1 equals to 17. Okay, if you subtract that to this side, you have 16 here. And you can divide this by 2. So you have 4a plus 2b plus c equals to 8. Okay, that's the second equation. The third one is negative 1, comma 2. So negative 1, I have negative a plus b minus c plus 1 equals to 2. And that equals to 2. So you have minus a plus b minus c equals to 1. Okay, I have 3 equations. Okay, which 2 equations you will start with? I will assume you all know how to solve 3 simultaneous equations, okay? Like, which one? Which equation are you talking about? The third equation? 2 minus 1 is 1?
Yeah, that's 1 is equal.
Why? Okay. Get it. Okay, let's have a look at the first one and the third one. You have positive A and you have negative A. You have positive B, you have positive B. You have positive C and negative C. Can you see A and C in the first one is positive, in the third one is negative? You can eliminate by adding them. If you add equation 1 and 3, you have 2b equals to 4. Then b equals to 2. Okay, b equals to 2. So let's rewrite that. If b is 2, a plus c will be 1 from the first equation. Okay, from the second equation, 4a plus c will be that's 2 times 2 is 4. 8 minus 4 gives you 4. Okay, that's the new equation 1 and that's the new equation 2. Okay, let's use equation number 2 subtract new number 1. That will give you 3a equals to 3. C and C can be eliminated. And a will be 1. If a is 1, c will be 0. So y equals 2x cubed plus 2x squared plus 0x plus 1. Okay, a is 1, b is 2, c is 0, and at the very beginning b is 1. Okay, everyone can solve it finally, but like how you can solve it easily? It needs to observe the equation first, and elimination is always better than substitution. Okay, when you have like more variables, elimination is always than substitution. If you can eliminate some variables, you can reduce the difficulty level. Okay, so try to use elimination more. So, and number 1, number 3 can eliminate easily. Okay, so that's this question. So when you have the points given is not the key feature points, not turning point, not point of inflection, not like in intercepts, then you will just use the general equation to work on it, and you need to solve like 3 or 4 simultaneous equations. Okay, any questions for that one? Then let's go to the next page. Well, let me have a look. Let's have a look at 6J first, the last page, because this will be included in the test, but like the middle, the 6I is not included, so let's do this first. Okay, 6J is application of polynomial functions. Well, application, you know, like we don't really need to be teach by any particular thing for application question. We know all the things already, and it just become like word questions. So example 1, a square sheet of the tin measured 12 times 12. 4, like that's not 4, is FOUR. Okay, 4 equal squares of HX centimeters are cut out of the corners, and the sides are turned up to form an open rectangular box. Okay, you know how to do it. Like you will fold up by those red lines. Okay. The value of x, find the value of x for which the volume is 100 centimeters square. First, for this box, like it's a rectangular box, what's the base? What's the length and width of the base, and what's the height of this box? 12 minus 2x. 12 minus 2x is a square, so 12 minus 2x is the square base length. And what's the height? X. Okay, x is the height. So we can write, okay, let's write a volume Vx needs to equals to length of the space times width of the space times x, which is the height. Okay, so this thing is the base. So base times height give you the volume. So it's 12 minus 2x times 12 minus 2x times x. Okay, B. Well, I can actually simplify this a little bit. I can take 2 out from here, 2 out from here. That makes a 4. So it's a 4x and form a minus x. That's minus x plus 6. Okay, and squared. And squared. Alright, and the values of x for which the volume is 100. So Vx equals to 100. Okay, Vx equals to 100. Basically, you want to solve for 4x minus x plus 6 squared equals to 100. But you can't solve by this form. You need to expand it. So 4x cubed minus 48x squared plus Well, let's not expand this first. Let's divide 4 first. Okay, you can divide 4 on both sides. That gives you a 25. That's easier. And x cubed minus 12x squared plus 36x minus 25. That equals to 0. Is that correct? Okay, now I want to solve for this. Let me try a value. Let me see if I can solve this by hand. Let's try whether I can factorize. Huh? 1. Okay, let's try. I'm not sure what is it. Like, I can't remember the answer. Let's try 1. That gives me 1. 1 times 1 minus 12 is minus 11. Minus 11 plus that gives me 25. And 25 minus that equals to 0. Great! Have it! Are you guessing or you have done that? Yeah. If you put 1, you have 1, 12, 36, and 25. And those numbers is very likely to make a 0. So 1 is always a number to start with. So you will have x minus 1 and x squared minus 11x plus 25 equals to 0. Okay. Can I further factorize that? B squared, what's the discriminant? Is b squared is 1 to 1 minus 4 times 25 equals to 21. I can further factorize it. It just become really like ugly numbers. It's just not a whole number. So how I can factorize x squared minus 11x plus 25? That will equals to x squared minus 11x plus half of b squared minus half of b squared and still plus 25 at the back. So you will have x minus 11 over 2 squared minus 1 to 1 over 4 plus 100 over 4. That will be x minus 11 squared, or 2 squared minus 21 over 4. So 21 over 4 is square root 21 over 2 squared. So that is x minus 1, x minus 11 over 2 plus root 21 over 2, x minus 11 over 2 minus root 21 over 2 equals to 0. Okay, come back a little bit. Tell me what's the domain, what's the possible value for x? What's the maximum value x can take? Can x be too big? Can x be 10? Then what's the limit? 6. Okay? On each side, you need to take 1 square. Okay, you have top 1 square, bottom 1 square. You need to have something left. Okay, it needs to have something left for the length and width. So 12 minus 2x is the length and also the width. That number needs to be greater than 0. You can't have a negative length. So 12 needs to be greater than 2x and then 6 needs to be greater than x. Then your x needs to belong to, okay, you need to at least cut something. So in between 0 and 6. Okay, you can't take everything. You can't just really cut everything. If you cut 6, if you use 6, then everything just gone. Okay, everything just gone. You can't have 6. You can't have 0 because you need to cut something at least to form this rectangle, to have a height. So x needs to be in between 0 and 6. Okay, let's back to this question. So what x equals to? X equals to 1. Or x equals to 11 over 2 plus or minus square root 21 over 2. Okay, let's have a think about 1 is definitely okay, right? 1 is in between 0 and 6. 1 is definitely okay. Let's think about 11 over 2 plus root 21 over 2. Is that alright? Why? Well, yes, that's the correct reason. Because think about what is root 21. Root 21 is in between root 16 and root 25. It's a number in between 4 and 5. Okay, a number in between 4 and 5. Let's think just 4. 4 over 2 gives you 1, right? And 11 over 2 is 5.5. Plus 1 extra is 6.5. It's out of the domain. So I won't have this number. Okay, I won't have this number. Okay, root 21 is in between 4 and 5. And divide 2 is in between 2 and 2.5. And then plus another 5.5 is definitely out of 6. So that is out of the domain. And let's think about the 11 over 2. Subtract that. Is that alright? Yes, that is alright. So for this question, x will equals to 1 or x will equals to 11 minus root 21 over 2. Okay, if you take 1, let's think about the Vx graph. Okay, let's think about the Vx graph. I read this too large. I have no space. Okay, let's think about the Vx graph. What's the graph will looks like? This graph has like 4 times x times minus x plus 6. I will have x-intercept. I'll roughly sketch it, okay? Okay, the Vx equals to 4x and minus x plus 6 times minus x plus 6. There must be a point at 0, 0. And there must be a point at 6, 0. And that is a turning point. My question is this graph start from the right top or right bottom? Top, 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 all agree, top. Okay, you have x. You have a minus x, you have a minus x. If you times them all together, that gives you a positive x cubed. Okay, a positive x cubed. So your graph will start from here. That's the shape of the graph. But you can only have this bit of the graph. Because it can't go over than 6. Can't go less than 0. You won't have negative volume and you won't have after 6. After 6 does not make sense. Okay, so it's only the red part of this graph. Okay. Make sure you understand you won't have other parts. Okay, next thing is that's the graph. Okay, remember that's the graph. It's a little bit like quadratic, but it's actually not a quadratic, it's part of the cubic. And this turning point is the maximum value I can take. But this turning point is not in between 0 and 6. Do you understand? It's not necessary to be in between 0 and 6. It can be in the middle. But like for cubic, it's normally not symmetry about this middle line for 2 x-intercepts. So the next question is asking the maximum volume. If I want to find the maximum volume, I need to find the maximum point. So how I can find the maximum point? I will use calculator to find that. Okay, after like term 3, you can do this question by hand. But like now you can't do it by hand. You must find that turning point. Then I'll put it into the calculator. So I have 4x times minus x plus 6. Wait. 4x times bracket minus x plus 6, and you square it. Okay, don't sketch this yet. Listen, okay, you need to know how to use your CAS. Because I only want to see the part in between 0 and 6, so I will restrict the domain. So press the control and the equal sign. You have this bar here. That is the given sign, like given that what x can be. So restrict it in between 0 and control equal. Choose the smaller and choose x. Control equal, smaller. Oh my god, this is really annoying. Okay, 4x times minus 6x minus x plus 6 to the power of 2, given that 0 is smaller than x, smaller than 6, and press enter. As you see, there's no graph because I changed this domain a little bit. I can't see the graph. If you can't see the graph, doesn't mean your calculator went wrong. It's because your window is not good enough to see this graph. You need to adjust your graph. So menu number 4, window and zoom. Go window settings. Okay, go window settings. What is your x? Your x is in between 0 and 6. So I will put 0 and 6 here for minimum and maximum. What's the y minimum? Your volume cannot go below than 0. So I'll put 0 is a reasonable value. I don't know what's the maximum I can have, but like the previous answer asked you to solve 100. You can achieve 100, which means this number must be greater than 100. I don't know how large is that, but I'll put the 200. See, try what I can have. And I have a quite reasonable graph here. And there's a turning point here. So if I want to find this turning point, I'll go menu, number 6, analysis this graph. And I want to see the maximum. This dashed line move to the left to the turning point. Press enter and you move it to the right of this turning point and press enter. That point is 2,128. Okay, 2,128. Before you do this question is good because it directly gives you a whole number turning point. Okay, a whole number turning point. But like most of the time in the VCA exam, you won't have that whole number values. You have decimals, and they will require you, for example, 2 decimals is like a common like rounding. But sometimes they ask you 4 decimals. If your setting is not correct, you can't see that many decimals. So if you ask you to round to 4 decimals, you at least need to have 5 decimal shown. Okay, 5 decimal shown. Go for menu and go to the setting. This setting is only setting for the graph. Okay, for the graph page. Go to the setting and change the display digit to a larger number, at least 10. Okay, at least 10. The display digits, like I put a 12, you can put larger numbers. Then if it's a rounding number, that will give you 12 significant figures. Okay, give you 12 significant figures. It's not 12 like decimals, it's 12 significant figures. If you have like 1 million something, that's already a lot of significant figures. And then there will be only a couple of decimals. So according to different questions, you need to adjust this float. So I would say put on a higher float, like 12 or something like that. Yep. Oh, sorry? Yep. I haven't really tried, but like I think fixed will be always give you, that's what I'm guessing, that maybe always give you decimals even though it's an integer number, but I'm not sure. I haven't tried that because I always use the float and it works well. I think maybe if you go fixed 5, that will give you 5.0000. That's what I suppose we'll have. It's okay. And make sure the graph angle is in radian as well. We'll learn that in circular functions, but like make sure that graphing angle is radian. Why I said that? Because this calculator has been changed compared to what I used before. Because what I used at that time is if I change the setting in this place, number 5, and the document setting, if I change the float here to a float 12 or something like that, like float 10, okay, and change angle in radian, that will change in both the calculator page and the graph page. That's the time what I did. But like I figured out in this calculator, if you change the document setting, it's only change the calculator page, not changing the graphical page. You need to change 2 places. Okay, does that make sense? Like you need to change once here for your calculator setting and change once in the graph page, and that's an important thing because most of the, like some students tell me, oh, why my calculator is not working, why the circular function is not working, and I see your setting is not changed in this page, that's why it's not. I said, but I changed it at the beginning. I said, no, it doesn't matter, must change in the graph page. So 2 places you need to change the setting. Okay, back to this. Yep. No, if you default that, that will be like set already. Okay, so 2 and 1 to 8. So come back to this page. What is the maximum? What is the maximum volume? That is 1 to 8 centimeter cube. So 2, 1 to 8. Can you see 2, 1 to 8? 2 is not in the middle of 0 and 6. In between 0 and 6 should be 3, but actually the maximum exists in 2. Okay? That's what I want to say for this question. And let's have a look at the next one. Take that off. 1 to 8. 2, 1 to 8. 2, maximum is the y value. Y value is represent the volume. Volume is 1 to 8, and x is 2. So when you cut 2 centimeters from each edge, that will give you the maximum volume. Yep. Next week maybe not, but like definitely exam time we will have that. Next week will, I think, focus on calculations, graphing, like all the basic techniques. Yeah, 1 page of notes. One side, I think. 1 A4 sheet. Example 2. It is found that 250 meters of the path of steam can be modeled by a cubic function. Can you see that's a cubic function? Well, I would say it's more like a circular function, but well, it says a cubic. Okay, it's a cubic function. The cubic pass through the point 0, 0. Okay, 0, 0. Where's my 0, 0? 122, 150, negative 10, and 200 and negative 20. So what I'll have is, okay, it's a cubic function, and I don't have intercept. Can you see I can't have x-intercept? Which I only have 1. Which is not helpful at all. So I will set up this as y equals to ax cubed plus bx squared plus cx. No d value because it passes through 0, 0. So d equals to 0. Okay, now I want to show you a really good thing. Okay, you must learn this, okay? I'm not sure how many of you know this, but you need to learn that. Okay, what do you know? Let's say that's fx. Let's not say that's y, that's fx. So what do you know? You know that f100 equals to 22. f150 equals to negative 10 and f200 equals to negative 20. Is that correct? Like according to the coordinates given to us. I can have those things. Okay. Come to the calculator. Go to the calculate page. Let's type this in. Okay. Type A. Okay. It's ax cubed, right? But in the calculator, if you're not using if you're not using x, y, z like as variables, if you use a, you must write times. Okay. Remember, a you can't write 4a. Make sure you times 4 times a. Okay. Because I don't have that question, but like in some question in VCAL, like the a, if there's a big difference if you type, for example, AB. If you write AB, that will be different. You type A times B. This number is not, this is some setting in the calculator. I don't know how to explain it, but make sure when you times those values except x, y, z, make sure you put the times on it. Do not just write ax cubed. Write A times x cubed. So A times x cubed plus B times x squared plus C times x. Okay, make sure you put the times in between. In some case it will work, but in some case it doesn't work at all. Don't take this risk. Okay, make sure you put the times in between. And now I want to define this function. The name I give this function is fx. Okay, it's fx. So how we define a function? We press the control, okay, the blue control button, and press this VAR. VAR is up above 9. You have this arrow here, and you can write the name of this function. The name of this function is f. Bracket. X is the variable. What is the variable? I put what in the bracket. X is the variable. Okay, so this means this function given a name as fx. Press enter. That has been done. So every time later you press fx, press enter, that will give you this function. Okay, that will give you this function. Now what you're trying to do is solve ABC value. Okay, it's to solve ABC value. Like it's not only helpful for fx. Let's put f bracket 1. Let's see what that happens. F bracket 1 gives you a plus b plus c. Okay, directly do the substitution for you. It's when x equals to what y value equals to. Now you want to solve. Press menu, number 3 algebra and number 1 solve. You want to solve 3 simultaneous equations. Okay, you press this thing right to 9 and press the last one. It's like 3 equations. Okay, you want how many equations? You want 3 equations. Okay, you want 3 equations here, you put it there. So what's the first equation? The first equation is f100 equals to 22. Just write f100 equals to 22. What's the second equation? Is f150 equals to negative 10. f150 equals to negative 10. What's the last one? The last one is f200 equals to negative 20. f200 equals to negative 20. What do you want to solve? A, B, and C, comma A, comma B, comma C. Even though you don't have A, B, C at all in this equation, but it's already involved in the fx. Press enter, it solved out for you directly. Okay, can you see how much work you have saved if you define this function and directly use fx instead of ax cubed plus bx squared plus cx? Okay, this is a really important way to save time. Okay, it's really important way to save time. And you have that value and you can write it there. Do I put it correct? 122, 150, negative 10, 200, negative 20. That's correct. A is 19 over 375000. fx equals to 19 37500 x cubed minus 23 over 1250 x squared plus Wait, why is that? Plus 233 over 150 x. Okay, the equation of this cubic is that. Find the maximum deviation of the graph from the x-axis in between 0 to 250. Okay, the maximum deviation will be either this length or this length. Okay, it's either this length or this length. How high go up or how high it go down. Okay, what I'm trying to do now is to graph this, okay, in between 0 to 250 and find the maximum point. Let's go back to this one. Okay, so I can copy this value and say that's control VAR, define this as A value. Okay, that's A. Copy that one. Control VAR, that is B. Okay, save that as B. And control VAR, that is the C value. Okay, let's have a look what my fx will equals to. My fx will directly be that. Because I have defined that A is that, B is that, C is that, your fx will directly become that. Okay, let's go to the another graph page. What I'm trying to graph, fx, right? Put fx there. Don't need to type the number at all. Put fx there. And then control equal to define that in between 0 and x and 250. See, we have the graph here. We have graphed it, but the graph is not the whole thing. It looks like a linear. Okay. Up to this point, a lot of students will come to me and say, why I have a linear for my graph? That should be a cubic. Because your graph is too small and this part looks like a linear. So we need to adjust the window. Okay, definitely it needs to be in between 0 and 250. But I don't know what is the maximum minimum. Let's put 100, negative 100 and 200 to try. 100 and 200 maybe is too large. Doesn't matter, but like I can see this graph. Doesn't matter. There's a maximum, there's a minimum. Let's put it up there. So menu number 6. First, I want to find the maximum turning point. Okay, left. Oh, wait. That's the minimum. Menu number 6. Number 3 is the maximum. Okay, here and here. That's my maximum. Can see that's a 12 significant figures. Menu number 6, number 2. That's the minimum. Can see this graph actually go up by 38.21 meters, but go down by 21.64. So it's actually go more up. Okay, the greatest deviation will be 38.21 if it's correct to 2 decimal places. Okay, if it's correct to 2 decimal places. So I will have that point is 54.46. 38.21, and this one is 187.64 minus 21.64. Okay, so B maximum deviation is 38.21. let's have a look at what happened here. Okay, let's have a look at what happened for the endpoints, whether the endpoint is greater or smaller than that point. Let's go back to here. What's the endpoint? Like, I mean, what's the x value of the endpoint? 250. Then let's say f250. It's really convenient. Can you see it's really convenient if you define it? You don't need to type the really large numbers. And that is 30. Okay, the endpoint is 30. 250, 30 is not over 38 yet. So you will have 38.21 is the maximum deviation. So basically you find where's the local maximum, like absolute maximum or absolute minimum. That's what you're trying to find. Yeah, so that endpoint is 0, 0. Okay. Back to the calculator. If you're trying to find, where's my mouse? Yeah. Okay. If you're trying to find this x-intercept and that x-intercept, you need to go menu number 6 and number 0, number 1. You want to solve for y equals to 0, and then you go to the left, you go to the right, you have that 133.485, 0. Okay, that's it's not asking you to do that, but like I'm just show you how to use this test. You need to, like, even though you have 2 x-intercept, but like you need to find them one by one. Now you find the first one, and then you go to find the next one, 6 and number 1. Okay, go to the left. Wait, it's lower bound is to the left, and then go to the right. That's 299.6728. Okay, skip. Okay, so I have 2 x-intercepts. I hope I can go through some CAS knowledge with you like during the year and get prepared for year 12, because CAS is a really important thing for your final exam. Like also like you know how to define fact functions, how to save some time by using your CAS. That will be really great. Otherwise you can't finish your paper. Okay, it's about like time management. Okay, so CAS is very important. Even though like you know perfect knowledge, but if you don't know how to use CAS, you can't get a good mark for your final exam. Okay, rely on CAS so much. Okay, any questions? Yeah. This one not. This one not. This is a test. Okay, let's